Hello. Right. Today we're gonna do some earrings, or yeah, you could use these also as other type of body decorations, but at least today we're thinking of them as earrings. And it's something like this. It's based on the infamous Voronoi diagram. If you don't know what the Voronoi diagram is, it's a type of tessellation, so a type of dividing an area. And it's quite used in algorithmic design, since it can give pleasantly looking, organic looking results. But it's also sort of a cliche because of that. But for an exercise as a starting way to learn grasshopper is fine. Plus, it looks nice, so whatever. Anyway, so we have here a curve which makes these cells smaller where near the curve and larger where the cells aren't that close to the curve. And the fun thing about this is that it's algorithmic, so let me show you. I'm gonna use like the basic Voronoi diagram without the offsets, because the offsets make it run slower and not react in real time. But I wanted to show you that you can go through all sorts of different variations. You can also change the profile of the curve and so on. I personally would do the earrings different, so not the same. And here we have a graph that controls how should I say? It controls whether the smaller cells are just in the near proximity of this curve, or they become larger in a more linear way, rather than being here really close and then starting to be large fairly quickly when you move away from the curve. Because a linear way to represent this would be sort of like this. But if you didn't get this part, don't worry about it. We will explain it later, and you don't really need to understand it that well in order to use it. But I think you get the point. What is this? Anyway, so let's start from the beginning. I'll just open a new Rhino file. Come on. New Rhino file. Rhino. Okay, so we're gonna use small objects, millimeters, as a template. Because earrings are small and we should work in millimeters. Okay, so let's fire up grasshopper, writing the first letters of the word grasshopper. And we get this blank grasshopper file. We will work basically in the top view, so I'll just maximize this. Okay, if we look at the The algorithm that is already done is not that large, and it sort of consists of 3 parts. The first one just makes Voronoi points. Then the second part makes these points be closer one to the other, where they're near the curve, and be at a larger distance where they are not near the curve, so that we get larger cells away from the curve and smaller cells near the curve. And the end basically gives some thickness to these lines and cuts the circle, because we want circular earrings. So going back to our blank file, let's just do for now the points with a Voronoi diagram, and without it being influenced by that curve. We could start with the circle, so the circle which represents the earring. So we can just double click on the canvas and search for a circle. Or we could go to curve, where we would expect to find the circle component, and we will use this basic one, circle, which needs as an input the base plane. You can also give the center in here, and it just uses a horizontal plane with the center, where you give the point here, and a radius. So for now, it actually did a circle because it has some default values. As a plane, it has the world XY plane, which is a horizontal plane which has the axis the same as the world, and the origin in the coordinates 0, 0, 0. And the radius for now is 1. And if you look at the grid, we have here this alignment for 1 unit, which is millimeters for now. But we're going to modify this. We're going to modify it because we don't want a 1 millimeter radius circle. We want, of course, a larger one. But before we do this, we're going to activate draw full names if you're a beginner, so we can see what the inputs and outputs exactly are without hovering with the mouse above the hooks. Actually, these are the hooks, but anyway, above the variable name. Okay, so let's do a larger circle. I'm fine with it being in the center, but I want it larger, so I'm gonna make a slider. I'm just gonna double click and write like maybe 55 or something. These are millimeters. If you want to be more exact, you can write 0.0 or 0.1 or something like this. And it will make a slider that has that value, but starts from 0 and ends to 100, right? If I would have written let's say 5.5, it will be between 0 and 10, not to 100. So if I input this here, I'm going to get a larger circle. But remember that this is the radius. And I think I prefer to think of the size of our earrings rather in diameter rather than radius. And in order to do this, so I want this to represent the diameter, this value here. So let's say we want 50 millimeter diameter for our circle. So the radius is how much? It's half of that, right? So we just have to divide this by 2 in order to get the radius. And we can do this, for example, like this. If you click /2 and enter, we will get a division, how do you call it, component, that has in the b value set to 2. You can change this if you want by right-clicking it and set data item and modify it from here. So let's just put it like this, and now we have a circle that has a 50 millimeter diameter, and we can rename this by right-clicking it and say earring, yeah, millimeter. All right. If you're not sure if it's correct, you can always go here, type distance, and then see if it's about right, and it is about right. Okay, we have the circle. Yay! Let's save the file before we forget, and we're gonna name them Voronoi Earrings. Is it with 1 R or 2 R? I'm not sure. I'll just leave it like this. Bam. Okay, and now we want some points in there, because we need the points to make the Voronoi diagram or tessellation. So in order to make these points, we can use this component that makes randomly positioned points within a certain area. And you can find that in the vector tab, because that is where usually components that have to do with points are. And in here at the grid we have this one, populate 2D, because we use it in one plane. If you wanted this to be 3-dimensional, we would use populate 3D. But anyway, so populate 2D, and we already got some points, but they're not exactly in our circle, right? So we have, let's see what input it needs. And I'm not going to start with the region, I'm going to start with count. Count is how many points you get there, right? And we can already put a slider there. For now it's 100, but I'm sure we will want more. So I'm going to put like this value, 1,000, whatever. It's easy because you click the same button, that's why. So count, boom, and now there are like a lot of points. I'm gonna leave them at a smaller value for now. What seed does? Seed is basically a number on which the random position of the points is calculated. Because as long as you have a certain number of points and the same seed value, you will get the same result. But maybe you don't want the randomly positioned points to be like this, but you want another configuration. Because, I mean, there can be all sorts of randomly positioned points within this area and with this count number. So this seed can be any integer. I usually just use something, I put a slider from 0 to 100, so let's write like 33, and if we put this into seed in here, we can see if we modify this, we get all sorts of different configurations for those points, right? Okay, it's a good idea to rename the sliders. Because you want, I mean, I usually put the input values at the beginning of the algorithm so that I have everything in one place, and you want to easily see what each does. So this is number of points, and this is random variations or point positions, let's say like this. All right. You also have these points, optional pre-existing population. You don't have to bother with this one usually, or at least not in this case. And going back to the first one is region. So, if you look there, it says rectangle that defines the 2D region for the point insertion. So unfortunately, I can't give any type of shape, at least in this version of Grasshopper, to populate with 2D points. It needs to be a rectangle. Actually, let's see if we can use this one, populate geometry, because this would make things easier. So I'm gonna use geometry here. Yeah, interesting. See, it doesn't use like the area; it uses the perimeter. But we can try something. I'm not sure if it will work. We can try to make a surface within this circle and populate that surface with points. So. Ooh, it worked. Okay, so this will make things easier. In my version, just so you know, because I think I just forgot about that component, the one with the cloud, populate geometry. I basically made a parametric like square around the circle. See? So if I modify the circle, that square modifies, and that square is used as a region for this. But I think it's probably easier to do it like this. So never mind this. Whoop, we don't need it anymore. And so this component is named boundary surfaces. You just put one or more curves in there, and it makes just them with the surface. So the output here is a surface, right? But this seems to work with all sorts of geometry, including surfaces, so yay for us. So count and seed, we're going to use on this. And again, we can just make more points if you want. But we don't want that for now, at least. Maybe I should top this value to, I don't know, 2000 or something. If you didn't see how I did it, I just double-clicked the name, and here at the max value I modified it. All right. Let's hit save again, and now, actually I'm gonna make this, I'm gonna disable the preview, so I don't really need that surface. Now if we put here a Voronoi, this one, the simple one, Voronoi component, and use these, which are the points for the Voronoi in points. Bam! We get already a Voronoi, and it looks kind of fancy, right? And we can use less or more points. Okay, but we don't really want this. We wanted to make it a bit more interesting and use that curve that makes the points be, the cells, the Voronoi cells be smaller near the curve. You won't actually see the curve, of course, when you build this, when you laser cut these earrings, but you're gonna sort of see its presence because of that, because the way the cells are in its region. Okay, so I'm gonna disconnect this. You can right click and disconnect. Bam. So this I'm gonna use later. We'll see how much later. I don't know. I'm gonna just put it around here somewhere. And maybe also make like this. I'm gonna make component, right click it, and write here points for Voronoi. Yeah, I think Voronoi is with an I, not a Y, but anyway. And you have to click this once, bam, so you get the name. By the way, if you don't have what's it called? The icons in here, all you have to do is click draw icons. You might also want to use this plugin that you have to download separately from for Rhino, which is bifocals. And if you install this plugin, you just double click the canvas, search for bifocals, and it is just this one component that you put anywhere on the canvas, and what it does is it makes the name of the cell appear above it. So you have both the icons, because you'll see it's easier once you get used to the program to look for the icons rather than the name. But you also have the name because you're just learning and you want to know the names of the components. So moving on. Yeah, let's make a curve. I'm gonna click curve in Rhino and just make a few points and maybe use this curve. You hit space at the end to confirm the shape. So now we have to reference it in Grasshopper if you want to use it in any way. In order to do this, you're just gonna use this curve component, which is just a recipient, or you can also use the general geometry component and not bother with the type of geometry, and click here. Let's say curve attractor. I don't know. I'm not sure if attractor is necessarily the proper way to define this. Attractor usually is a shape that actually no, it's fine. Attractor because it's used like this. It's a shape that influences the geometry some way. In its proximity. But sometimes it actually attracts shapes. For example, you could have like, I don't know, cones that have or pyramids that have their tips towards the attractor. Anyway, so we have the attractor, and now we thought of different ideas to make these points be closer together, where they're near the curve, and farther apart when they're farther away from the curve. And a fairly easy way to do this is to make like a lot of points and then just delete or make the points that are farther away from the curve have a bigger chance of being deleted. So we're gonna use a lot of points here. We're gonna make like something like this. And now for each point, it's sort of gonna have a chance of being either deleted or not deleted, right? And we're gonna calculate this chance, and then we're gonna use a simple comparison function or component in order to see whether the point gets deleted or not based on a random value. It's sort of like playing roulette or Russian roulette. And you know Russian roulette? You put like...
Is there a number and then...
It's the one With a bullet. No, so normal roulette is the one with the ball. Russian roulette is where you usually you put a bullet in one of those pistols that has I don't know what it's called, like 6 slots, and then you go like this and then you shoot yourself in, and you see if if yeah, okay. So it's sort of like that, and basically it means that the farther away the point is from the curve, the more bullets are there, so the higher the chances that it gets deleted if we want to make like sort of a comparison. Okay. So first thing is, okay, how do we check how close or far a point is to a curve? And there will be like 2 ways to do this. A simpler way, which I'm gonna show, and a more complex way, but I would say a smarter way to go about things, which is using vector fields. I'm not sure if I'm gonna get into that in this tutorial. But the simple way is like this. So we have the points for now. They are here from population. Let's make another component like this to actually write, to easily see them, and we're gonna say initial points. Okay, back. Okay. And we can make this disappear so we don't have this doubling of points. And what we want now is to check the distance from each point to the closest point to the curve. And in order to do this, there is a component named closest points or something like that. If you write CP, you usually find the components that involve closest points. And we will use this one, closest point. So not closest points, because we don't need like the first 3 or something like that. We just need 1. Actually, it's a bit stupid that it's not just this one value, but anyway. So use this one, closest point without the S. And, nope, sorry, not this one. This is for points being closer to other points. But we need the closest point to a curve. So CP again, and we have, where is it? Oh, come on, this one, curve closest point. Yeah, sorry, I made a mistake. So the curve attractor goes to curve, and the initial points go in here. So now, let me also put the curve in there because I didn't. So right click, set point geometry, and select the curve. And now this works, and we get for each point the closest point on this line. But we also get the distance from the initial point to the point in there. I'm gonna make this not show because I'm not interested in seeing all those points. I'm interested in the distance, because the smaller this value is, the smaller the distance is, the higher it should have a chance of living, or the smaller is the chance of it getting deleted, right? Okay. So, because this distance is important, these values are important, I'm gonna put here a number recipient like this, and I'm gonna name it point value, or values, or points values, I don't know, points values, let's say like this. Right, so I can easily find it. So based on these numbers, I can also put a panel in here, although I don't really need it, just as a reminder. We have all these values, which is the distance from each point to the closest point to the curve. Okay. We're gonna do like this. What are we doing with these distances? Well, First of all, we're gonna make all these values which be within 0 and 1. And you'll see a bit later why we do this. Because we're gonna use a graph mapper component which is usually between 0 and 1. Because for now, you see these values are like not between 0 and 1. And we can actually see exactly what the range is using bounds component. What this one does is like this. If you put here a set of numbers, it gives a domain. A domain is a type of value. It basically means from this number to this number. So if we look at the domain, it says here, come on, 0.02 to 23. So this is the range. But this value, of course, will be modified if I start and modify the size of the earring, for example. It probably will be modified also if I start modifying the seed value and so on. I don't really want to bother with this range. I just want to make everything between 0 and 1. It's easier to work with. So. Okay, so in order to do this, we're gonna use a simple component, but very valuable one, which is named remap. Remap numbers. Bam. And this has 3 input values. Value is basically the numbers. So point values, this one, the numbers. This is what we want to remap. The target is the target domain. So in which domain do we want this? And we want it from 0 to 1, which is the default value in here. See? Target domain 1 locally defined value 0 to 1. If you wanted something else, we would have used this one from domain, this one construct domain, and here you put a number and here another number, from number to another, and then plug it here. But it's fine, the default value here, 0 to 1. Or you can also change it like this, set domain, and write different values here. Alright, so as a source, what is the source? The source is again 0 to 1, and it won't give proper results if it's like this. The source needs to be the domain of these numbers, which we found out with this component before, right? So this we're going to use it here as a source. Alright. So now we have the mapped numbers. We can actually verify this if we use this component again for the mapped values and see if we get 0 to 1, and we get 0 to 1. Alright.
I don't have my glasses, so I try to see well.
Yes, you can go like this.
Yeah.
So these are the distances mapped from 0 to 1. Again, I could use one of these, maybe in case you don't remember, I use this, which is a recipient just, and right here, like remap distance values. Okay, and click here once, and here we go. Okay, so we're not gonna use a graph mapper for now. And I'm going to explain to you what a graph mapper does. But we're not going to use it for now. So let's do this without using graph mapper. And it's like this. For each point, we will get a random number. That random number will be between 0 and 1. Okay? The farther a number is, the farther a point is to the curve, its value is closer to what? To 1, right? Okay. And we want it to have a bigger chance of it being deleted, right? So the bigger number, the bigger distance meaning, the higher chance of it being deleted. Let's say we have a number, can I take this? Let's say we have a value for a point around here, which is 0.75, right? So it's quite far. We're gonna get a random. We're gonna get a random number for this point, which will be between 0 and 1. 0.75, it's around here. It's like 3/4, right? 0.75. I just made this. So we have 0, 1 in the other part, and 0.75. So if we get a random number here, let's say we throw a ball in here, it can land anywhere. But we said that we want the bigger chance, since this is farther, to be of it being deleted, right? Okay. So otherwise said, if we want it, if this random number turns out to be between 0 and 0.75, for the point to get deleted. And if it's between 0.75 and 1, not to be deleted, right? I just made it with a dark color, right? So if it's between 0 and 0.75, if the random number falls within this domain, we want it to be deleted.
That's why, because if we say the curve is 0, so it's not the more far, the numbers that are the more far away from the curve that's going to be deleted, but the ones that's the most close.
Can you repeat?
If this part is the part where the yes, but if we say that 0 is the curve, is the most
the closest to the curve, yeah.
But so
right.
Why it's not this part that is where it's deleted, because it's the most far away part. You understand what I mean or not?
Yeah, but you're making a confusion. Maybe I can explain like this. Let's say you have a point which is its distance to the curve is like 0.01, so super close to the curve, right? So you have this domain. Here is 0, here is 1, and here is 0, 0, 0.01, very close. you will get a random number in here, which can be anywhere. You want the chance of it being deleted to be very small, right? So it will be, if it falls within this range, then it gets deleted from 0.001. So the chances are super small for it to get deleted.
Oh, okay.
So yes, it's just a way to use numbers. It's not.
It's
something that.
yes, like it's a area of that if it's from here to here, of course it's more, the chances are bigger.
Yeah,
But why don't we do it like from 0.5, for example, to 1? We cannot do that.
Oh, what I mean,
Like-
this point, which can be 001 or 0.75 or anywhere between these, is the numbers here, the remap distance values, right? So the closer a point is to the curve, this separation of the domain is going to be closer to 0. And the further it is, it's going to be in here. And you always know that the first part is the one that means delete. And the last part is the one that means no delete.
Okay. Yeah. But for me, it's not logic. Like it should be here, or no? But if it's,
Maybe I should
if
pause
it's
this and
off-
test. Let's continue. Yeah, I was saying, I don't know, maybe it helps. Let's say we have a point which starts here, from distance 0, or distance value 0, which means it's very close to the curve, or actually on the curve. And this means it's the farthest away from the curve. If we move it away from the curve, this part, the first part of the domain, which means it being deleted, increases. So the further I move the point, the bigger the chance of it being deleted is, and the smaller the chance of it not being deleted or leaving is. Okay, so in order to delete these points, we're going to use a component named call pattern. What this does is, within a list of values, it doesn't matter if it's geometry or numbers, we're going to use geometry, meaning the actual points, which are here, initial points, these ones, right? We're going to have a call pattern. Call pattern, to call means basically to delete, right? And pattern, in this case, means a pattern of true and false values. True means it remains in the list. False means it gets deleted, right? Okay. And how can we get this pattern? Based on our logic here. Well, let's get our first example. We have a point which has a remap distance value of 0.75, meaning it's quite far, right? And we're gonna get a random a random value between 0 and 1 for this point. And we want, if that value is between 0 and 0.75, for the point to get deleted. Or otherwise said, because we can also say it otherwise, if it's between 0.75 and 1, to remain, right? Okay. So we can do this the following way. If we say like this, if our random point is actually we can verify, like, is our random point, our random value higher than the remap distance value, or higher than 0.75. So let's say it's x, I don't know, let's call it x, our random value. So each point will get a random value between 0 and 1. And the idea is that this random value, it will fall between 0 and 1, but within that domain between 0 and 1, it might have a smaller or larger chance of it being deleted. And this chance is based on the distance. Okay. So if we use like this, if we check to see, is our random value larger than our remap distance value? And if it is larger, then we have true, right? And in the call pattern component, it means that that point will remain. If it falls in here somewhere, we will get false, because our random value will be not larger than 0.75, right? So we will get false and we will get deleted. So what we need here is to check if our random value is larger than the remap distance value, or otherwise than the distance, but it's not actually the distance because we shrunk everything to fit between 0 and 1. That's why I'm not saying just distance. Remap distance value sounds complicated, but it's not. It's just the value of, it's basically an interpretation of the distance of that point. Okay, so in order to do this, we're gonna use, as I said, we're going to check if our random value is larger than this value. So larger than. We don't have the random values yet, but we're going to generate them very shortly. So here we're going to have random values. I'm just going to copy this and say random values for the points, and oops, I disconnected this. You can also disconnect by holding Control key and making the same connection again with Control. Bam. And these are the remap distance values. So, again, for each point we're going to have a random value between 0 and 1, and we're going to see if that value is larger than the remap distance. Okay? And the thing is that the further the point is, the harder for that value to fall within, or the harder it is for that value to be larger than the remap distance value, because the remap distance value gets closer to 1, you know? So this part where it lives gets smaller and smaller, so the chances for the random value to be here are smaller. Okay, so how do we do random values for the points? We use random, this one, which has a cat in a box. Okay. So again, let's see what it needs. First of all, I'm gonna put this a bit higher because I don't want to see that wire. Range, meaning between in which domain does it make the random value or values? And it's 0 to 1, so it's fine like this. number of random values. We already know what seed means. It just generates other random patterns. Okay, so how many values we need? As many as points, as initial points or point values, right? In order to check how many these are, we're going to use this component named list length. So this is a list of elements, and if we use this, we just see, okay, so it's 552. And this, of course, since everything is algorithmic, gets adapted automatically if we change the number of points. This just gets adapted. Okay, so now we get as many random numbers from 0 to 1, as many there are points. We can again also use a slider for the seed. I'm going to leave it here for now. And we're going to use the output of this comparison if it's larger than. So if the random value between 0 and 1 for each point is larger than the remap distance. Because the distances are also between 0 and 1. 1 being the farthest away, and so the farthest point, and 0 being the one that is closest to the curve. And we're going to use the output as a call pattern. We have two outputs here. We have larger than, and we have larger or equal to. It doesn't really matter because probably we won't get some that are actually equal. So you can use either. I'll just use this. Okay, so let's see what happens. So it already works quite okay, right?
The red one on the false, and
Yeah, exactly.
the green one are the true.
The green one are the true ones, and we can modify the seed value, and we will get similar patterns. But again, you can go through different variants.
And we can also move the curve.
Yeah, of course. So if we modify this, I don't know, if we make it like this, see, it adapts. All right. Let's call this randomize
Pattern. Point pattern.
yeah, like point deletion. I don't know. One. I don't know if deletion is an actual English word, but anyway. Since I'm gonna put this at the beginning, I don't want this wire to cross everything in here. You can do like this, right click and click wire display hidden, and then you see the wire only if you select either of these. And I'm gonna put this also here. Alright, so these are the points, and we can put it in here, and yeah, we have a Voronoi. If you want to see just this, we can either select all these and click the head which is blindfolded, or select the end result and click this, show selected all. And it's pretty nice, but I think it would be nicer if we would have a more dramatic difference between the points that are close and the ones that are farther away. And the idea is that for now, we have like a linear progression. I'm not sure how to name it. Let's think of it like this. A point is very close to the curve, okay? Chances are almost full that it won't get deleted. And this one gets deleted, but between these, so between the extremes, how should I explain this? Like a linear progression. The chances of it being deleted grow linearly, meaning that a point that is at half the distance will have sort of half the chance of it getting deleted. If it's a quarter close to the curve, then you will probably have like 3/4 of a chance of it leaving, and 1/4 of it getting deleted, and so on. But we can make this not be linear. We can make it like the points that are here close to have a high chance of remaining, and then like
We can just change this, in fact. And then
no, I'm gonna show you right away. We can make it that the points that are really close to have a high chance of getting deleted, and then sort of quicker get into less of a chance of it leaving. Yeah. So the middle point will have like a bigger chance of getting deleted than just half, sort of like this. So we get bigger cells in here. So it's just the progression won't be linear. It will
yes,
be
increase like this.
yeah, something like this exactly. So in order to do this, sorry, I'm not exactly sure how to explain this, like linear progression, or it can be otherwise, and otherwise it can be like conic, or you'll see, because we have a component that just does this, and it's easy to use. So that component, right, that component we're gonna use. Where are we gonna use that component? Well, we're gonna use that component in here. So we remap the. I wrote points values. Let's say just point distances. Distances. We remapped the distances to be between 0 and 1. Remap distance values, okay? And in here, let me put a graph mapper, this one. I'm gonna put it in here, like this, okay? And we have graph types, and I'm gonna choose for now conic. But it's a line, it's just a line if I don't modify it. I can modify it in here like this, or I can use also a linear, and again it's a line. If you have a line, a diagonal line like this, it means nothing gets modified. Because basically what it does is it puts the numbers in here, which are from 0 to 1 on OX, and based on this graph it sees what the value it gets on OY, which is also 0 to 1. So in here, if we have like 0.5 for example, it will get 0.5 in here. If we have 1 in here, we'll get 1 in here, and so on. Nothing gets modified. But let's use a Bezier, for example. If we modify this, and actually I want to see only the end result. If we modify this to be like this, for example, in here, if we have a point which has a distance of 0.5, see? And here we'll have a bigger value, which means it will have a bigger chance of it getting deleted. So we can play around with this until we find something that we think looks good. See, it already works quite well because we have these small cells in here and bigger ones farther away. I wouldn't modify this, although actually you can play around with this also, as you can see. Ooh, cancel. And the thing is that Graph Mapper has these values between 0 and 1. You can modify this if you double click them in here, but you can, at least for now, Grasshopper doesn't know how to, or doesn't let you modify these domains parametrically. So that's why it's best to just remap the values between 0 and 1, because you can also use this, and you also have values from 0 to 1. Actually, if we put this in here, if we lower this, the biggest value will be here. It won't be 1, it will be smaller than 1. But if you like how it looks, that's fine. So this is also an input. I don't know if we could put it in here, something like this. At the beginning, so you can play with it when you are searching for your design. So I'm gonna make all this nutshell, so I can see the Voronoi pattern in here. And again, number of points, maybe we can make even more. So the cells are smaller there, but you might not be able to cut this, right?
Yeah.
Okay.
And how the...
Let me save it again. Yeah.
How the circle is, because now we don't see it.
Yeah. Okay, so let's see the circle. But we also want to cut it, okay?
Yes,
yes. Yeah. We're gonna do like this. We first would want to give thickness to this, and then cut it, because if we don't give first thickness, so what means giving thickness? Means basically making these cells somewhat smaller. If we don't do this at first, if you want to fillet the corners, to make the corners round, we will have some problems with the cells in here, because we're going to get some cells that are not strictly polygons, but also have curved parts. Actually, that shouldn't be a problem, but in my other algorithm, it was a problem. Okay, so for now, let's say we don't want thickness, we just want to cut this. It's easy to do. You go to intersect, and I believe in here. In here we have these Boolean elements or components that refer to region. Region means basically a closed curve. That's a region, right? So a curve that defines a certain area. And we're gonna use intersection, which means that the cells that are, let's say, this cell, this one. If we intersect this cell with the circle, it will just keep the area which is present for both areas. So like this, I can show.
Okay.
Yeah. And the ones that are fully within the circle, it will let them stay like that. So in curves B, we're going to use the circle, and in curves A, we're just going to use our Voronoi cells, which are these ones. We can also make a component for this, but I mean, it's easy to see, it's not a problem. The problem is that Boolean intersections, Boolean, what do you call it, functions usually take a lot of time. So when you're searching for your idea, it's best that you don't let it think further, because it will really struggle. Because if so we got what we wanted, right? We have this. But if I modify the curve now, it will stay a few seconds to update. And you don't want this when you're searching. So what you can do is you can, for example, double click the wire. Come on. And you have this component relay, and you can, oops, yeah, sorry, again, double click the wire. Yes. And then select it and turn it off. So now the information doesn't go further. Okay. And now if I want to modify this, I just get instant feedback. All right. So this is how you do this. And let's give some thickness now. Here we have a bit of a problem. So normally you would use the offset component, which is within Grasshopper. Offset curve. Okay, so you put here the curves, and you put the distance. Let's say 0.11 or something. This is the distance. And see, you can modify. The problem is that it offsets it on the outside. It makes the cells larger, but we want it the other way around. So we want this to be the negative. So you can double click, write neg from negative, and it just puts basically a minus in front of it. And now, it actually did a good result. No, because when I tried it, some cells didn't work. It made some errors. So I got another offset component made by the author of Grasshopper. He made that component for another Grasshopper user on the forum. And yeah, I wanted to use that one, but let's modify it a bit and see if it makes any problems. And if not, maybe we're lucky, I don't know. So all cells seem to be okay, right? Yeah. Okay, then we just use offset. If it doesn't work, you can ask me for that component, or if I put this on YouTube, maybe I'll link to it on the bottom. This is my other algorithm. But anyway, let's go back to our new one. So this is pretty much done. You can make this round if you want, the corners round. They are going to be a bit round anyway from the laser, because the laser basically makes a round hole. So the corners are going to be a bit round from the laser. But otherwise you can use this one, fillet, and use radius, let's say 0.11 here also, and see how it looks like. So if you make this higher, see, they get rounder. All right. Round corner, because maybe you're not familiar with the fillet term. Wire hidden, because I want to put it at the beginning. What was this? Oh, this is the thickness. But again, this is done on both sides, so the thickness is actually double.
Okay.
So if you want to input here the thickness, we need to divide it by 2 before we use it, right?
Why?
Because
Because it's
the offset is on both parts, see?
Yes.
So 0.
Oh, so you want to just have one
So
part.
0.18 or whatever the value here is in that part, in that part. But when I think about it, I want to think, okay, I want the thickness to be
Yes,
that
just-
much.
Oh, yeah, okay.
Okay, so we have to divide this by 2 before. So divide by 2 and put it here. But I'm going to show you another way to do this, a more elegant way to do this. We can implement divided by 2 and negative in here directly with an expression. So I'm going to put this here directly, right click it, expression, and always the input is named x. So we're going to have minus x divided by 2, like this. So these 2 we don't need, it's everything in here. Okay. I'm going to make this be hidden as well. And I'm going to take this and put them at the beginning. You can also like put them in another order here if you would like. You can also select them and with this arrow put them all aligned. I don't know if I can modify the wire
How did you
here.
do with your arrow? Like, how did you?
You select the components
Yeah.
and
Oh, okay.
you have here.
Okay.
You can also, if you click this, it makes them equally distance.
Okay.
Not at once. All right. So we are almost done. Oh, I showed you last time. You can also let's use a 0 fillet for now, and you'll see. So round corner 0. I'm gonna cut the flow of information there so I can get instant feedback. And we also had this one, radius, if you remember. So we can put here like something like this. And if you think you want some cells that are not like fully developed, something like this, I don't know if it can give a nice result. Let's see.
I prefer the other.
Yeah, I don't really need it, right? Yeah. So we tried. Never mind. Bam. So now all we have to do is make the outside circle, and
Something maybe on the top.
to hang it. Huh?
Yes.
You tell me. Okay. Before this, maybe we want to do. I'm gonna show you something nice. So instead of using this relay and
Yes.
the
Make it on off.
yeah, you can do it better like this. Whoop. I hit the left alt key to do this if you're curious. So instead of using this, we're gonna use like this stream gate. This is the stream, so the information that is needed. And let me quickly change this to hidden also because it's annoying. And the gate means that the information goes either in here or in 1. Okay? But in order to use this, effectively we're going to use also uh, not a button, but a toggle, Boolean toggle. And we're gonna put this in gate. So Boolean toggle is a component that lets you double click it, and it goes between true and false. True and false are also 0 and 1, it's the same thing. So if I look in here, it's actually 1 when it's true. And if it's 1, it goes to in here, to 1. And how do I do this? How do I use this? So for 1, I'm gonna put it in here. Curves A, right? So meaning, here I'm gonna, instead of Boolean toggle, I'm gonna say make thickness. And if it's true, the information, the cells go out in target 1 here, and they were used before, because before these two were just connected like this directly.
Okay.
But if I double click this and it's false, the information goes to target 0. So in this output.
Okay.
And it's not used. So I can put this at the beginning and easily change between the two. And actually I'm going to do something else in here. Because when it's true, see, it takes a lot of time, that's why I use. When it's true, I want to see the curves, but I don't want to see these middle lines as well, right? Okay. Therefore, this I'm gonna make not to show. And I'm gonna leave just this, or actually I can put another curve element in here and say like final cells, okay? So that it's easy for me to, or for you to see where you have the final cells, right? Okay. So, therefore, unfortunately this one, I think it shows what flows through it, so I'm gonna make it not show. And so when it's true, I only see this, and when it's false, let me put it to false, I don't see anything because it doesn't use the information in any way. But if I put here like a curve component or a geometry component, this will show. Okay? So when I want it to move quickly, so it doesn't make thickness, I'm seeing this. And if I want the thickness, I double click this one. This component doesn't get any information because it gets out here. It makes the offsets and everything. And when I get the final cell, so this is just great. And I'm gonna put this somewhere around here, I guess. I don't know, at the beginning because. Actually here, just above this two. Ooh. Oh, save. Okay. And I was saying that it just needs it needs another circle. So this is the initial circle. It made that offset, so the cells are a bit smaller, but I think this distance is too small. So we're just gonna make another circle. I'm gonna go at the beginning, and this circle, I'm gonna duplicate it. And the radius, I want it to be this one plus a value. So, addition. gonna be this one, which is the radius for this circle, plus another value, a few millimeters, let's say 2.2 millimeters or something. And we have the other circle, and actually this one I can make not sure. And the smaller this one is, the smaller that outside thickness is. Okay, and now if you want, we can also make that like a small thing with a hole in it, if you want. Okay, to make that, let me save this. In order, let's write here like outside thickness, okay? Outside the ring thickness. And I think I'll put it in here. You can also use this wire display faint, which is just a small one. You see it, but it doesn't bother much. Alright, if you want also a small thing to hang it from, we're gonna make another circle. Bam. And we're gonna make like this. Point on curve. Point on curve. This is the curve. And we're gonna get a point on the curve, which is in here when it's half. When it's 0, it's in there. If you want it to be on top, it probably needs to be a quarter or something. You can right-click it and choose a quarter. See? But you can also move it around if you want it to be in another place. So this is gonna be the plane. It's not actually the plane. I mean, it's the center of it, but it makes a plane with that dimension. We can put another, modify the radius if you want, let's say 1.1, and I'm gonna click here like, what do you call this? I don't know. I know in Romanian. I'm gonna name it hanger, although it's not really a proper name. Maybe use actually 2 decimals to define its size. Put this in the beginning. Maybe this point on curve also on the beginning. And okay, so we have these two at the beginning in here, and we want to make it just one shape between the big circle and this one, right? Yeah. Okay, so the big circle is this one, and this is the other one, and in order to make one shape, you go to intersect, again to region union. And you're going to put this circle, and then click shift, and put this one as well. If we look at the output, we get this. Okay? And again, we can like move it around if you want. Alright. So I'm gonna make this not show. We have this. And I think we should name this curves like exterior cutout or something like that.
There is a hole here or not?
Not yet.
Okay.
Cutout or contour. There. Because we're gonna have to bake this, right? As well. So that we have it in right now and export it for the cutting. Okay, and in order to make, how do we make a circle here?
We can make another one.
Yeah, for the whole. So we're gonna use again the circle component. This one. We're gonna use the slider for the radius, maybe 0.9. Let's make this be the diameter by putting here, oh come on, by putting an expression x above 2, so divided by 2. This way we have diameter here, so let's say hanger or diameter, okay? This one uses radius, so it just, yeah. This is gonna be at the beginning in here also. Let me make this, put this higher. Maybe also get all of these, group them with Ctrl G, right click and say hanger. Alright, and also I want to make the wires faint like this because it bothers me otherwise. I don't know why it doesn't work at the end, but anyway. Okay, so but the circle is in the middle for now. We want it to be in here. And that point is where? That point is the result of this one, point on curve. Again, if I would have put here a recipient and named point for her, something would be easier to get, but come on. We don't have to do this each and every single time necessarily. So, boom. And now it's where it's supposed to be. And I'm gonna make another recipient is gonna be named like hole. Hanger hole. Hanger hole. And so now we pretty much have everything, but we don't have to forget that yeah, the thickness of the cut is 0.2, but unfortunately I forgot if it's 0.2 on both sides or just one side.
No, you made just one side. You made it like
No, so I know from building this that
you mean the
when you cut it with a laser cutter, I know that they told me that the thickness of the cut is 0.2, but I think it's 0.2
maybe it's
overall.
better to make it more thicker.
Yeah, exactly. Because if we want to have this thickness, we actually need this, but because let's think if we cut it like this, we're gonna have 0.1 in here and 0.1 in here, so the thickness will be 0.2 less. So you always have to think the thickness to put 0.2, but it depends if you want to have like a visual representation of how it would look like, or if you want to make the final thing for the cut. So if you want visual representation, you leave it, I don't know, with the thickness that it has, and if you want for the cut, actually you can do like this. Again, we can use stream if you want. I don't know if that's, I mean, you can just modify it in here and think how much is plus 0.2, or you can make something like this one that you double click, and if you double click it, it just puts 0.2.
Okay.
But I'm not sure if I think the tutorial is long enough. I mean, even if you understood this with the stream component, you can probably make something similar in here to add.
Okay.
Actually, I can make it really quick. Stream and and gate, and this is the stream. So I'm gonna have to make this connection in here, right? And you will have again a toggle, a Boolean toggle, and when this is set to true, the information goes in here. And here you make a add and plus something. And then you also have to stream it to gate it. Not to gate it, to... Yeah, never mind. You also have to like make the two streams go into one single stream, but maybe that's for another tutorial. Okay, so now that this is finished, you can remake it, choose the shapes, and then cut it. Because you have everything at the beginning. Let's make this point not show, like this. You have all these like elements. When you're searching for the shape, you put this to false, make thickness false, so you can get rapid feedback, and